4.4. We're going to do both of these today, but we're only doing the factoring parts of these lessons. We'll save the equation parts for tomorrow. So let's just review factoring. Steps to factoring. And if you were here, it's there. I have y'all frozen. All right. So if you were here on Friday, we reviewed some factoring from Algebra 1 so that today can go a little bit smoother. So if we're factoring a polynomial, the first thing we looked for is the GCF. Now, what does GCF stand for? Greatest common factor. And so if we have a greatest common factor, we factor that out of the polynomial first. The second thing we do is we count our terms. Now, our polynomials will usually have 2, 3, or 4 terms. So if we have 2 terms in our polynomial, we want to check to see if it's a difference of squares. And we'll talk about these today. If we have 3 terms in our polynomial, it's a trinomial. And we make tables to solve them. If you were here Friday, we did some of that. Also, in the 3 terms, there is a short way and a long way. And we will talk about both of those ways today. And if there's 4 terms, we're going to use factor by grouping. All of this we did in Algebra 1 for like a month. And the last thing you have to do when you're factoring, after you count your terms and factor accordingly, is make sure all of your factors are completely factored. So that's how we make sure our answer is in simplest form. So those are our 3 steps to factoring. Step 2 has different little branches, different directions we can go. So if you know those steps to factoring, when you come across a problem, you'll know exactly what to do. What's the very first thing you should always do if you're told to factor? Look for the GCF. Number 1 thing all the time. Number 1 thing all the time. Y'all put your pencil down when you have those copied down so that I know that we have it all written. All right. So today we're just factoring polynomials. And we're going to use that to help us solve equations tomorrow. So we're just practicing factoring today. So everything we're doing today is something you already did in Algebra 1. I promise you. Yes, and then some. No, it's mixed up. It's all mixed up. No. Okay. So, let's start with one really simple. 5x minus 25. What's our first step we have to do? Find the GCF. So if there's a GCF involved, then we can factor it, and maybe we won't have to do anything else. So what is the GCF between these 2 terms? 5. And if you weren't here Friday, the GCF is the largest number that goes into both the numbers. And if there's variables involved, you pick the smallest if they have it in common. So 5 is our GCF. So what we're doing here is we're unmultiplying. Okay? So I need to know what times 5 makes 5x.
1.
What about the x? X. Right.
I want to put 1 and we put 1.
You can. On your paper. I'm not. I like mine simplified. And then what times 5 is 25? 5. And then you can check it. If I distribute 5 times x minus 5, do I get 5x minus 25?
Yes.
Yes, because 5 times x is 5x and 5 times negative 5 is 25. So this is my factored form of that polynomial. That one's done. Okay? Bless you. Next one. X squared minus 9x plus 20.
What you gotta do, make it short.
All right, first we got to look for a GCF.
We multiply to get 20.
Hang on. I said first we got to look for a GCF.
2.
Is there a number that goes into all 3
4.
terms besides
No.
1?
2. No.
No, because this leading term is 1, so the numbers would have to be 1, and they all 3 don't have an x, so the GCF is 1. So therefore we go through to step 2, which is how many terms do we have? 3. So we make a table. So when you make your table, you're going to use the last term and the middle term on these problems. Now we're going to have more difficult ones later that we have to do a little bit more work to, but this is one of the easy ones. So we want 2 numbers that will multiply to get the last term, that will add to get your middle term. You're ahead of me. What's the middle term? Negative 9. Okay, we got to keep it slow. First examples for sure, okay? Sorry. So now we want to list some factors of 20, and we want to run across one that will add to make negative 9. Now let's just think for a second. If we're multiplying to get a positive number, and we're going to add to get negative numbers, what kind of signs do I need?
Negative and positive.
Both negatives. Because to make it to multiply to be positive, I need it to be both negative or both positive, right? Because a positive times a positive equals a positive, and a negative times a negative is a positive. So, positive 20, I can do negative 1 and negative 20. What else multiplies? Negative 5 and negative 4, and just to list all of them, there's only like one more, negative 2 and negative 10. Right? Which pair of those will add to get negative 9?
Negative 5 and negative 4.
Very good. And when you write your answer, you just take those factors and put them in binomials. My variable is x. So I have negative 5 and negative 4, so I'm going to use x minus 5 times x minus 4. And those are my factors, x minus 5 and x minus 4. Don't put any symbols or anything between the 2 parentheses, because right now sticking them together means they're multiplied. If you put a plus or a minus between those 2 parentheses, that makes it wrong. Okay? So just keep them squished together. Any questions on this one? Okay. We're just mixing them all up today. N squared minus 49. And I don't think we did any of these on Friday. So, first thing we look for is the what? GCF. Does this one have a GCF besides 1? No. So then what's step 2?
Count terms.
Count the terms. How many terms do I have?
2.
2. What does it say for 2 terms?
Difference of squares.
See if it's a difference of squares. Now, a difference of squares is when you have a binomial, which means 2 terms, and both terms are squares. So is n squared a square? That's one of them. Is n squared a square? Is 49 a square?
No.
That means you can take the square root of it, right? Is 49 a square?
How do you know if you take the square root of it?
If you take the square root of it.
And it comes out even.
Yes. A whole number goes into it. Okay?
So 7 times 7 is 49?
Yes. Yes. Okay. Yes. So this is this term squared minus this term squared. Right? I meant to write that in red. Y'all forgive me. Y'all understand that? So what you do when you have a difference of squares? You figure out if they're both squares. If they are, break them into their squares. And then you're going to make 2 binomials. This one, the front term square root goes in the front. The last term square root goes in the back. And when you have a difference of squares, you need opposite signs in the middle. Opposite signs in the middle. So the factors of n squared minus 49 is n plus 7 and an n minus 7. And you can reverse the order. You can have n minus 7 and n plus 7. Okay? Let's do another one. Again, I'm mixing them all up because I don't want you getting stuck on thinking we have to do something the same way every single time. What's step 1? Is there a GCF of size 1? 3 goes into 1? No. So the GCF is 1, right? What's step 2? Count terms. How many terms do we have?
3.
So we make a table. So I need 2 numbers that multiply to get what number? Negative 12. Watch your signs. And add to get what? 3. And if they multiply to get a negative, what kind of signs do I need? A negative and a positive. And if they add to get a positive, that means the bigger of those 2 numbers needs to be a positive. Right? Because when I add 2 negatives, the answer keeps the sign of the bigger number, correct? Okay, so what's some things that multiply to get negative 12? Okay, and I'm writing my bigger numbers with positives. And that's all that multiplies to get 12, right? Do any of those add to get 3? Nope. Don't work. So guess what?
No function. No solution.
Well, we don't say no solution. We just say it cannot be factored. Cannot be factored. Now, these are going to be rare. If you get these on more than 2 or 3 of these on your homework, then you're probably doing something wrong. But did I just say it cannot be factored because I was lazy and didn't want to do it? No, I proved it, right? I proved it, right? I showed my work and says I tried everything that multiplied to get negative 12, right? So, and if none of them added to get what we want, then you say it cannot be factored. But you have to try every single thing that multiplies to get that number before you can say it can't be factored. Does that make sense? Yes, sir. Trinomials like this, yes. But if you can do it in your head and get it correctly, I'm okay with it. But if you can't get it correct, I better see the work.
She better see that. If she don't, she can't know.
That's right.
3. You might even get out 4.
Depends on how many there are.
Right.
All right. That was this one. La 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 la. Now what about this one? What's the GCF?
1.
How many times? Make a table. I need 2 things that multiply to get what?
12.
And add to get.
4.
What signs do I need? A negative and a positive, and the bigger one's negative. That's right. So it can be like this. Negative 6 and 2, right? So I go straight to my answers. X minus 6 and an X plus 2.
So easy. I learned this in kindergarten.
No, you learned in 9th grade. Let's do this one. Just trying to keep it mixed up.
You want to do that number C?
Oh my gosh. I'm stuck.
What's the first thing I do?
No grade on coming. GCF.
GCF. If y'all don't do GCF first on this one, because it really is also a difference of squares. Okay? But you need to do GCF first because that helps you simplify it down all the way. So what is the GCF?
2.
That's not the greatest.
4.
4. So what times 4 makes 4x squared?
1x.
X squared, right? Minus what times 4 makes negative 36? Negative 9.
Negative 9.
Now go to step 3. Make sure everything is factored completely. Now, how many terms are in here?
2.
So I need to check to see if it's a what? 2 terms.
Different squares.
Difference of squares. So is this a perfect square? X squared?
No.
Yes.
Yeah, because x squared is x squared, right?
9 is squared, 3 and 3.
And 9 is 3 squared, right? Now you can do what I showed you a while ago, or you can do it this way and just do it in your head. What multiplies times itself to get x squared? X, put it in the front.
Plus 3.
And what multiplies times itself to get 9?
X minus 2.
Just answer my question. 3. That goes in the back. Opposite signs in the middle. So all of this is your factored answer. If you leave off the 4, it's wrong. So make sure you drag your GCFs all the way down. Any questions?
No, man.
All right, I'm going to give you some you tries, and I'm going to give you quite a few. So I want you to practice them real quick right now and make sure we know what we're doing. Okay. Follow all the rules, count your terms. Look for GCFs first. Well, you got to practice it. Practice it means your pencil touches your paper. And skip it. There's 30 other problems.
The number that does not have a variable you multiply by. The number that has a variable you add by. Correct?
Yes. All of these are factorable. Well, yeah, I think I gave you all factorable problems. I know I did. So if you get something that cannot be factored on these, double check. All of these, I promise you can factor. Write them all down. You need a positive and a negative. Like literally write them down. Now we've got to know our times tables to do factoring. That's just it, point blank. How are we gonna get good at this, y'all? Practice. Practice is how we get good at anything. I'm not getting good at the piano this week because I haven't practiced. Be honest, that is true.
What do you, after you work about what you're doing now?
They have to do it, so they don't have to.
Okay, you got these two? Then you have it right here. You got X minus X. That's it. If you got two binomials, we're good. That's your answer. Move on. That's trinomial. So you need two numbers that multiply to get negative 63 and add to get positive 2. You need a positive and a negative. And the bigger one is going to be a positive.
Multiply is 63. Negative 60.
Yep. Yep. Try those. They do add to get 2. You need a positive 9 and a negative 7.
Baby.
Thank you.
I know y'all time tables.
I cheated my way through.
Not even funny. Well, This is where it comes and smacks you in the booty. Shh. I'm glad you know your ABCs. But this isn't preschool. All right, they are going to get more difficult after these, so it's important that we try to understand these. We're going to go over them together right now. Number 1, is there a GCF besides 1? No, so we count our terms. How many terms does number 1 have? 2. So if there's 2 terms and it don't have a GCF, what do we look for? Is this one got 2 squares with a minus sign? So it is a difference of squares. So you can go ahead and make your 2 binomials if you want to for a shortcut. What multiplies times itself to get x squared? Put them in the front. What multiplies times itself to get 16?
4.
Put it in the back. Put a plus and a minus. They can't factor anymore because I don't have any more differences of squares. If this one had a square on it right here with the minus one, it would be a difference of squares, but it does not, so it is not. So this is my answer for number 1. Raise your hand if you got that one right.
Does it matter what comes first?
No. Yes.
So if you think number 4 on the second x.
You would have x plus 4, x plus 2, and an x minus 2. You just keep on factoring until you can't factor it anymore. All right. Number 2. How many, is there a GCF besides 1? Nope. So how many terms? 3. So we're going to make a table. We're going to make a table on the rest, all 3 of the rest, right? So we need 2 numbers that multiply to get what? And add to get what? -3. Now we need a positive and a negative because it multiplies to get a negative, and the bigger one is going to be a what? A negative. And we know that because whatever sign this one has, it's going to add to get that sign. Right? So what's some things that multiply to get 18? All right, so I need the positive one bigger. So 1 and -18, 2 and -9, and 3 and -6. Do any of those add to get -3? The last one. So we need an x plus 3 and an x minus 6. And it doesn't matter which one you put first or last, as long as the minus goes with the 6 and the plus goes with the 3. Y'all with me? Raise your hand if you got that right on number 2. Good job. Number 3. This time we're multiplying to get -63. And we want to add to get a +2. What kind of signs do I need?
Positive and negative.
Uh-huh. And the bigger one's going to be a what this time? Positive. So what do we know multiplies to get 63?
9 times 7.
And that's the only thing I know that does that besides 63 and 1. I don't know. Is there any other numbers that multiply to get 63?
Did I know?
Okay, so
9 times -7.
does -7 times 9 add to get 2? -7 plus 9. Yeah. So, okay, notice that these variables are R's, right? Did y'all notice that? So your answer really should have R's on it. And I got a -7 and a +9. So make sure, again, the plus goes with the 9 and the negative goes with the 7. Did y'all get that right on number 3?
Yes,
Even if you oversighted and put an X, I'm good for now. It's not test day. And the last one needs to multiply to get what?
81.
And add to get what?
18.
-18.
You're going to be -9.
Yeah, we need 2 negatives, and that adds to make -18, right?
Now,
So what do we write?
W minus 9. W minus 9.
Is there another way I can write that answer?
W minus 9 squared would split on
Very good. Very good. Is anything times itself is the same thing squared. So either one of those answers is correct. Raise your hand if you got one of those two answers for number 4. Very good. Any questions? All right. Quite a bit. But it's all Algebra 1. You've done it before, so technically not hard at all. Number G. No, can't do it. Letter G. We'll start with this. Me too. We ain't quitting.
We ain't quitting now. Don't wait till later.
Now these are trinomials again. The GCF is 1 again. However, these are different because the leading term is not a 1. There's something in front of x squared. Okay? So I told you when there's 3 terms, you got to check to see if it's the long way or the short way. Well, this is going to be the long way. If you have a number in front of the x squared that is not a 1, then you got to do it a long way. You're going to start it pretty much the same. You're going to make the table. But your multiply number you're going to get from first times last. First number times last number. So in this case, it's 3 times 8. What is 3 times 8? 24. And we're going to add to get 10. So this one came from first times last. Now these are all positives, and I did the first one positives on purpose. So we want some numbers that multiply to get 24 and add to get 10. Does anybody know 6 and 4, 2 and 12? There's a few more that multiply to get 24, 8 and 3, 1 and 24. Do any of those I listed add to get 10? The ones he told me, 6 and 4.
3 and 8.
Yeah, but that's going to add to get 11. All right, so after you figure out what multiplies to get first times last and adds to get your middle term, you cannot go straight to your binomial answers. If the leading term is not a 1, say this one's a 3. If it's not a 1, you cannot go straight to your answer. You have to factor the long way. And here's how I'll do factor the long way. You want to copy this first term, just like it says.
3x squared.
Okay, stop. We need to focus and just be quiet and let me explain it the first time around so everybody can understand. Because it gets confusing when people are hollering things and people get it and people don't. I want y'all to see how we do it. Okay, so I'm going to use my 6 and 4. And where I'm going to use it at is I'm going to substitute them right there in the middle where that 10 is. Okay? So I'm going to substitute right here. Wow. Impressive. You're fine. All right. So they're both going to get an x. So I'm going to put a plus 6x and a plus 4x. And then copy the last term. So what I have done is I've taken this 10x and split it into 6 and 4. Because does 6 and 4 make 10? Yeah, so I've just done a substitution there. Okay? So now, how many terms does my polynomial have? 4. And when we have 4 terms in a polynomial, we use factor by grouping. Factor by grouping. And I'm going to show you what factor by grouping looks like. Now, grouping obviously means you're going to have grouping symbols, which are parentheses. Right? So I'm going to put parentheses around my first 2 terms. And parentheses around my last 2 terms. Now what you're going to do within your parentheses is you're going to do the GCF. So I'm going to do the GCF for this blue parentheses, this first one, and I'm going to do GCF for my second blue parentheses. Okay? So ignore the second parentheses for right now and just look at the 3x squared plus 6x. What is my GCF? 3, and they both have an x, don't they? So if they both have an x, which one's the smallest? X is, right? So 3x is my GCF for the first parentheses. Okay? And then we're going to do it just like we factored it before. What multiplies times 3x to make 3x squared? x or 1x, same thing. Plus, yeah. What times 3x makes 6x? 2. Okay. Copy the plus that goes between those parentheses. Then you're going to do the exact same thing again for the second parenthesis. So this time we're looking at 4x plus 8. Now what's the largest number that goes into 4 and 8? 4. And do they both have an x?
No.
No, so I don't put x in there, GCF. So just a 4.
X plus 2.
Do what?
X 4 times X.
Yes. So it's 4 parentheses. What times 4 is 4x is x. And then what times 4 is 8 is 2. So it's x plus 2 in parentheses. Now what do you notice here about both of your parentheses? They're the same thing. They both have an x plus 2. So this is the easy step right here. We're writing down the answer now. We can go straight from here to the answer.
So
Not squared. One of them is x plus 2. The other one, y'all remember? The other one you get from writing down everything that's not in parentheses squished together. So put it in parentheses, 3x plus 4.
what if they're not the same?
The parentheses better be the same or you didn't do a GCF correctly. So one of your binomials will be from the 2 parentheses. It should be the same thing repeated. The second one should be from the 2 things on the outside squished together. Okay? Let's practice another one like that. Let's do 3x squared plus 20x minus 7. All right. GCF is 1. How many terms do we have? 3 terms. We're going to make a table. Is this one going to be a short way?
Negative 21.
Like I said, is this one going to be a short way or a long way?
Long one.
How do you know?
Because it's not 1.
Yeah, this is a number besides a 1, so we got to do the long way. Close. We're multiplying to get what number?
21. Negative 21.
Negative 21. It's 3 times negative 7. So watch your signs. And I'm squished, I'm sorry. And I'm adding to get positive 20.
21.
So I need a negative and a positive.
I need negative 1.
Hang on a second. I need a negative and a positive, and the bigger one will be a what? Can y'all please answer the questions I'm asking? A positive. Thank you. So go ahead. What were y'all saying? 21 and negative 1. Does that add to get 20? Yes. Okay. Now we said this was long way. So remember to do the long way. We're going to copy the 3x squared. And then we're going to place the 20x in the middle with these 2 terms with an x. Now y'all look. I'm going to help you make it a little simpler. If you've got one of each, this works out a lot easier, Lee, if the plus sign is in the very middle of the whole problem. If there's a plus sign in the very middle of the whole problem. So I'm going to swap the order of these 2. Okay? I'm going to write a minus 1x, a plus 21x, and then copy the last term. I'm sorry, my table's kind of in my terms over there. So, yes, you can write plus 21x minus 1x, but I don't like to have a minus in my problem in the middle if I can help it. Sometimes you can't help it. If I have one of each, I like to reorder it so the plus sign's in the very middle. It just helps on our signs a little bit. So now I have 4 terms, so I'm going to use grouping. Bless you. Group the first 2, group the last 2. And then we're going to do GCF twice. Okay? Any questions so far? All right, so look at that 3x squared minus 1x. What's the GCF between 3 and 1?
1.
This one. What about x's? Do they both have an x? So what's my smallest? X. So 1x or just x is the GCF. Is everybody okay with that? So what times x makes 3x squared?
3x.
3x. Minus what times 1x makes 1x? 1. Right? Because anything times 1 gets itself back. Copy the plus in the middle. And then we're looking at the parentheses with 21x minus 7. So what's the GCF between 21 and 7? 7. Do they both have an x? So do I put x in GCF? I do not. So just 7?
3x.
So what times 7 makes 21x? 3x. And what times 7 makes negative 7? Negative 1. Do I have the same thing in both parentheses? Yes, and I should. If not, we messed up somewhere. Okay?
Can you guys just look at it and be like 21? Can you guys just look at the simplest side?
You can't just jump. You have to make sure because sometimes weird things happen. Yes, sir.
If they're going to be the same on each side every time, we're not just be easier to.
That's what he was saying. That's what he was saying. But sometimes weird things happen that we have to fix it to make it the same. So, and those are really, really rare. But yes, you're supposed to notice it happens, but I want you to double check it. Does that make sense?
You can look at that.
Because you still, yes, but you still got to do the GCF.
Yeah.
But then you can double check it and make sure that when you multiply it, you get that to start with. Does that make sense?
Okay,
so what are my two binomials? One of them is what?
3x
minus 1. And what's the other one?
x plus 7.
Yeah, I meant to highlight that. Yeah, it did highlight. You squish all the stuff that's not in parentheses together, and you get two binomials.
There is so much going on.
You know it. This is about 2 weeks of Algebra 1 all in one lesson. Welcome to Algebra 2. Let's do another. Let's do one where it has to be a negative. 5x squared minus 17x plus 6. That clock is not existing. Did we? GHI.
We're going to have to do that crazy long way.
The table, and it's going to be the long way, right?
So it's 30.
So I need two numbers that multiply to get first times last is 30. And add to get the middle. Very good. What signs do I need?
Positive. I mean, both negative.
Both negatives. Y'all agree both negatives? Okay. So
you got 3 and 10.
negative 3, negative 10.
You got 31. You got
Negative 5, negative 6.
Miss Isbell,
Yes.
Addison Eubanks is checking out.
Okay.
Thank you.
15 and 2. Good. I'm writing down your problems. Page 255. 3 through 20. Page 263. 3 through 20. It's 34. Hey, these won't be due until day after next, though. We're going to turn in all this stuff together, and we're doing it 2 days on each one. Yeah. Yeah.
In other words, don't do your homework tomorrow.
No, I wouldn't do it because you got about that same amount added to it. Okay. Tomorrow's we add to it. I need to add Jared's negative 2. Do any of those add to get negative 17? Which one? Yes. Now, these are both negative, so we don't have to really worry about the order. So, copy the first one. And those two replace the x in the middle, so a minus 15x.
So we got 2 negatives.
So that's why I couldn't put a plus in the very middle. So that's when things get a little bit hairy in just a second. So I got 4 terms. So now I group. What is the GCF in my first group?
5.
Keep going.
5x.
5x. Parentheses. What times 5x is 5x squared? X. Minus what times 5x is 15x? 3. Very good. This time I'm copying a minus right here.
2.
And then we look at the GCF is 2 for the next group.
X.
And what times negative 2 is negative 2x, and that's positive x. What times?
Plus 3.
Yeah, a negative 2 is a positive 6, though.
Oh.
-3.
Uh-huh.
Hang on.
This is why it gets confusing. Because when you have a negative in the middle, you have to say what times this negative number makes this
Hang on,
positive.
where'd you get the -2 from?
The GCF you told me was 2. I brought the minus down from the middle. That's why minus is in the middle, make it a little funky.
Okay.
But there was no way around this one.
So -3.
Negative 3.
Yep.
And again, we can do like Coach Sway said, go ahead and copy it, but double check. Is this times this negative 2x? Is this times this a positive 6?
Sometimes.
It is today. It is today. So now we can write down our answer.
Okay, you got x minus 3,
And
5 minus 2.
5x minus 2. Okay. Very good. All right, so we've got a few more little simple things to talk about, and I think they're going to be a little easier. That was probably the most difficult thing.
How many more we got here?
4 more examples. But like I said, I think those are the most difficult. That's the hardest thing we'll do all day. J. We're going to factor this. First thing we look for
Squared.
is a...
9 is squared and 64 is squared.
You didn't answer my question. What's the first thing we look for?
GCF.
Is there a GCF besides 1?
No.
Not this time. Okay. So, is it a difference of squares? Because we got 2 terms.
Yes.
It really is. So, we'll just go straight to it. What multiplies times itself to get 9x squared?
3x.
3x. Put them in the front. What multiplies times itself to get 64?
That's 8.
8. Put them in the back. Are all of those factored completely?
Is there a way on the calculator?
No, you can
find
factor again,
squared.
You can do square root.
So you just keep 1 squared, 2 squared. You got to keep going through until you find.
No, you can do a square root. Type in square root. Hit the yellow button.
Okay, 64.
No.
Yellow.
Clear it out. Yellow button.
The second button.
Uh-huh. The x squared is diagonal from the 7 key. Do you see one that says x squared? You don't hold it.
Look, like here.
Show 'em.
Second, boom, then
64. Enter. It's 8.
60. Look, not color, print, look. Second.
You don't have to do parentheses.
Second, boom.
3 buttons.
Okay.
This. 64.
Okay.
There you go. All right, so that one was nice and neat. Let's do this one. JK. Well, yep, I'm not kidding, but we'll do 2 more examples. La 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 la. Oh, let's do this one. Let's see. 4y squared plus 20y plus 25. This is just like what we're doing, right? GCF is 1. How many terms do we have?
3.
3. So we make a table. I want 2 numbers that multiply to get what?
25.
No.
I've got to add
25 would be 100.
100. And adds to get 20.
10, 10. Yep.
This is special. It's called a perfect square trinomial.
Okay. So
Yeah.
you do.
Long way or short way?
Oh.
Long way.
What's the short one?
You just go straight from table to answer. So if this was the answer, you just say y plus 10 and y plus 10.
No. But
Okay.
it's got a 4 and so
Yeah, it's got a 4, so we can't do that.
4 got squared plus 10
10y plus 10y plus 25. Now what do I do when I get to 4 terms?
How come you put on the top of that?
Because this one had a y and we broke it into 2.
You got the group.
And the first one, I copied the first one. You've had this many x's. I just changed it to y's this time. All right, so we got to do grouping. Y'all tell me what you think is the GCF in the first group.
2.
2y. Good. Parentheses. What multiplies times 2y to get 4y squared? 2y. Plus what times 2y equals 10y? Just 5. Good. What's the GCF in the next group?
5.
They're so fun. What times 5 is 10y? 5 times 5 is 10? Okay. Plus 5. And what's my answer?
2y plus 5.
Hold on.
2y plus 5.
2y plus 5, then 2y. Just put 2y plus 5 with the square.
Yeah, you could write it 2y plus 5 squared. So either one of those is correct. Okay. That's called a perfect square trinomial. Because it took a square there and it added up to a square. One more. And it's easy. It's easy.
I don't know when you'd ever use this in real life.
Well, you need a high school diploma, and the state of Tennessee says you need Algebra 2 for that, and this is Algebra 2. So here we are.
Let's go.
One more. Y'all tell me what I'm going to do first. GCF. What's GCF? 5. Parentheses. What times 5 is 5x squared?
X squared.
Minus what times 5 is 45?
9.
Am I done? Step 3. Make sure it's factored completely. Is x squared minus 9 factored completely?
No, they're both squares.
They're both squares, aren't they? Yep. So keep the 5 on the outside. If you leave off that GCF, it's wrong.
3. X minus 3 on X on each side. X minus 3.
And then 3. And what goes in the middle? One's a plus, one's a minus. So all of that is my answer. And that is the end of factoring lesson for today.